Hello, YouTube viewers. Welcome to my show, Future Friday. In today's episode, we're going to talk about warp drives. So let's dive right into it. Well, what is going on around here? Basically, we are talking about something that travels faster than light. Basically, 300,000 kilometers per second. We want to exceed that speed. Now, general relativity on the matter is very clear. Basically, you can travel at light speed only if you are 100% mass less, basically like a photon. If you have mass, there is a graph that you can plot how much energy it requires to travel faster and faster. Now, in that mathematics, you can simply plot out what it will take to basically reach light speed, not faster than light speed, just light speed itself. The answer would be infinity. That's the problem. Basically, if it takes infinity just to reach at light speed, how the heck you gonna cross it? So that's not possible. That is why the moment we learned about this, light speed as a final barrier that we cannot pass, then people started to create science fiction stories around it. It's like, okay, what if we can pass it? Basically, you have Star Wars, you have Star Trek, you have Battle Galactica, and countless more. Now, on top of that, it's not just a storytelling element. You also have to understand this. If we can figure it out, if we can truly travel faster than light, we can do interstellar travel. Because many times you have to understand, even if we are traveling at light speed, let's say somebody created something that travels light speed, or let's say 99.99% speed of light, removing time dilation. Let's say you removed time dilation for the crew, because time dilation will only happen for the crew, not for the people on Earth. Basically, you will have a scenario where it takes 4 years to go to Alpha Centauri, like 4 whole year. So that is a problem. Like, if you want to really do galactic level civilization like Star Wars or Star Trek, you have to have faster than light travel. Okay, then what is the reason behind this all the hype recently? Basically, there was a seed idea. The idea was created by Miguel Alcubierre in 1994. Now, he created the idea. Now, what he did was very clever. Basically, special relativity, relativity and special relativity was saying, no, you cannot go faster than light. So they took the mathematics and inverted it. Basically, what it would take to do that. Basically, same way you have E equal to mc square. What if you have mc square and then you try to figure out the E? Basically, we do that in mathematics. It's quite normal. So he created a solution based on general relativity. So without bypassing it, using general relativity itself, because we know for a fact that general relativity is true. Now again, resolution of that theory can be proven in the future, that we could have even better resolution, but right now we know for a fact general relativity works. There is no discussion about it. It works. So first thing he realized, you cannot go faster than light. That's it. You cannot go faster. However, there is a catch. The catch is the space itself can move faster than that. Basically, space-time itself. Think of it this way. We are here on Earth. We observe one galaxy that is moving very fast in this direction. Now, how do we know that is moving and it's moving fast? Basically, Doppler shift can help you with that. Now, Doppler shift is telling you, yo, that puppy is going fast and is going very far. What if you have something here, some other galaxy, and that is moving far and very fast? So what about the distance between them? Is that distance increasing faster than light speed? The answer is yes. Now, have we actually find this out, actually tested it? Yes. Hubble telescope, do every James Webb telescope, when it's ever get launched or something like that, we'll find out that with more and more details, because we have enough evidence, like actual evidence, actual photographs from actual measurement, astronomical measurement, to tell us that yes, space-time itself can expand faster than light speed. So basically, you can have a scenario where after the let's say very long, like few billion, trillion, hextrillion years in the future, you can have a scenario where all the galaxies would have moved so far, so fast. So we could have a scenario where light from those galaxies will basically would be traveling, that will be so far apart, the gap between us would be expanding faster than light. So no new photons will reach us, and the photons that have left before the light speed was created, it would be so redshifted, it will go into background radiation, background noise. Basically, we cannot detect it. So the science is there. Basically, you can expand space-time faster than light. So he took that and created a mathematical model on that. Now he just created what you call a base, a foundation, how to do this, not a complete drive. Now again, in science, no one person can do everything, but you have to understand. Now he created the idea in 1982, then people started to add on to it. Some people were like, yeah, this does not work, because you have to understand, when he created the mathematics, the answer was you need more energy than the entire equivalent of the universe itself, not the galaxy, the universe itself. So flat out, people are like, yeah, it's a good fun mathematical experiment, good thought experiment, but not really practical. However, then you have the person known as Harold G. White. Basically, that's why you will many times type basically Alcubierre-White warp drive. So this person comes along and is like, okay, he's basically responsible for a lab in NASA that is known as NASA Eagle Labs, basically advanced propulsion and power systems. They deal with magic voodoo things basically. If there is even a remote scientific hypothesis that this might work, they will test it out. They are not the people who are like, let's build a methane engine, let's build a a propane engine or things of that nature, like SpaceX. They are doing something far out, like, oh, you want to build a time travel machine, you go to them. You want to build faster than light travel, you go to them. You want to build a magic EM drive, you go to them. These people will test it out. So he made it more practical. He did the mathematics basically same way Newton had the mathematics, and then comes along Einstein and refines the mathematics. Same thing happens here. He comes along, he refines the mathematics. So he, at the first glance, he does some mathematics and all that with the geometry improvement and all that, and he's like, okay, let's reduce the energy consumption from universe to size of the Jupiter itself. Again, manageable comparatively speaking, but you are still talking about the Jupiter. And he not only that, he is like, okay, there is mathematical something on paper. He created this interferometer, basically wide Judae warp field interferometer. Now the idea with that is that actually test the warp drive. Now, what I mean by testing the warp is he's only meant to test the warp system. Is there a warping happening or not? If the warp happens properly, and they are still working on it because this instrument is so sensitive. Same problem happens with the EM drive. If the instrument is too sensitive, you will have way too many false positives. So they are still testing it, and soon they will move into vacuum chamber testing and high vacuum chamber testing. All that they will do that. But the idea with that is, if even a remote warping can happen, like warping of space-time, not faster than light travel, just warping itself, they should be able to detect it using this instrument. So basically you can understand, he took some mathematical idea, refined it, made it more quote unquote feasible, then he built an instrument to actually like test it out whether the warp can happen or not. That is why like so much momentum recently has been pushed into the warp drive system. So, okay, what is the science behind it? Basically, okay, people are working on it. These are scientist people. These are actually qualified people. So, what is happening, like in terms of scientific front? Basically, you are moving the space-time itself. You cannot travel faster than light. Flat out, you cannot. So, the best analogy you can think of it is in this way. Rather than like how we have doing anything. Basically, you're traveling on something. You are traveling inside something, like a submarine. It's not a boat where you are rowing things. So you are just like moving the things around you. You are creating a warp. So, space-time is the sea for you. Now, you will move the space-time itself, and you will do that by creating a bubble. Now that bubble will expand and contract ahead or behind of you based on how you want to travel, and depending on how quickly you can do that, not the travel itself, how quickly you can do that. And if you can time it right, you will end up moving forward in in space, and you can move faster than light, because there is no mathematics that says this cannot be done. Basically the same way the two universes that are expanding away, there is no mathematics that says, hey, gap between these two things cannot be exceed the light speed acceleration. Same thing is happening here. It's like you are creating a bubble. That bubble is moving faster. You are not moving faster. That bubble, that warp bubble is moving faster. And there is no limit on warping itself. Basically, their mathematics, even they pushed it to like 9,000 light speed or 10,000 light speed. The reason 9,000 was used because it's like in Star Trek TV show, the person got inspiration from Star Trek itself. So that is why. So warp factor is like, in the mathematics and all that. So that's the science behind it. You cannot travel faster than light, but you can make the space-time travel for you. Okay, how the heck is gonna do that? What is this? How the heck is gonna do that? Well, same way we have matter and antimatter, we have gravity, and we must have anti-gravity. Like mathematically, it must be there. So the idea is either you're gonna take negative matter or energy, because matter and energy are interchangeable because of equal terms square, and then you're gonna do the warping. So that negative matter will interact with the space-time. Now you have to understand, I'm talking about constructing or warping space-time. Now, if you make a rod of space-time, let's say this is a rod, mathematical rod, which is made out of space-time. This is a rod made out of steel. Now here's the steel rod is so flexible. Compared to this, it will look like it's made out of nothing, and the rod made out of space-time would be like diamond. So you have to understand this. It is very hard to bend space-time. Now, do we bend space-time? We don't, but stars do, black holes do. So you get an idea, because bending space-time is not some voodoo concept. We do that. It's just to do it well, to do it enough to like create gravity. It requires a tremendous amount of energy. So then the mathematics started to happen, and he came up with the idea, donuts, the donut back and front, and this will create the field. This is the reason, like the original drive had just no mathematical architecture to it. That's why it was requiring power equivalent of like freaking universe. Now, once he created the donut architecture, it's like, okay, power went down to Jupiter level. Now, then he realized the space-time is very hard. So how do we cut hard objects in Earth? Basically, we oscillate it. So he's gonna do high frequency oscillation on these tuners. This will soften, quote unquote, soften the space-time, and that will allow you to consume less power. So basically, it's the same way we have ultrasonic glass cutters and all that. So that high frequency oscillation will allow us to make the warp much more efficiently. Rather than consuming like, Jupiter sized fuel tank, we're gonna need like 700 kilos of that. So that's how it works. Basically, you have something that negatively interacts with matter, basically space-time. We know matter reacts with space-time, and we have observed the effect, and that's the whole point of weight and all that. So it does that. Everything is tested about. It's just we have to find negative of that. Then we have to create this geometry. Geometry has been tested out. Like mathematically, the geometry works out. So we create the geometry. Then we oscillate this option to reduce the power consumption, and voila, we have our warp drive. Now, can this be real? Well, this is something like, okay, if you have this fuel, we can drive a car that will, run on like, this power for 50,000 years. Something like that. Now, problem is, where is that fuel? Now, in this scenario, the fuel is negative matter or energy, depending on that. Now, where this idea that we can even attempt to have something like that? Well, think of it this way. We are doing a recent observation of our universe itself, suggested that our universe is expanding. Okay, everybody knows that. What's so fancy about it? It's accelerating. Basically, it's supposed to be expanding, let's say, at 1 light speed. It's expanding at 2 light speed, and next time we measure it, it's expanding at 3 light speed. It's accelerating. The expansion is accelerating. How the heck that is happening? So, we did all the math, and then we created 2 blank spots. The blank spot 1 is dark energy, blank spot number 2 is dark matter. Nobody understands what dark energy or dark matter is. It's just something as a placeholder. Like Neil deGrasse Tyson said, is something very interesting. It's like these things should have been named, George or Hulalala, something like that. Basically, we do not know. It's like a mathematical concept of like, putting X variable, find out Y or something like that. So whenever somebody says dark energy or dark matter, you have to understand it's a placeholder. We know it exists. We have observed this effect, but we do not know what it is, how it works, how it has this kind of effect. We do not know. So it's unknown. So that itself has that property that we are looking for, the negative property basically. So based on that, people are like, yeah, we may be able to like, somehow make it. Because think of this, like we have matter here, we don't have antimatter, but can we make antimatter from normal matter? Yes, that's what particle accelerator do. So same way, we are hoping that somehow we can figure out in the future like what is dark energy or what is dark matter, or are they interchangeable, or can we make normal energy into dark energy, or can we make normal matter into dark matter? If we can figure that out, then yes, mathematically this becomes possible. Now again, that only solves the mathematical aspect. After that, when you actually start to build the basically ship and all that, I have provided a very interesting basically 1 hour long interview with that person, which just happened like 3 months ago. So it's quite recent, and you can figure out like when he was doing the math, he was figuring out like brake will be running away from you at faster than light speed, so you will never be able to apply brakes, and that same will happen with accelerator. So you will never be able to get to up to the speed, and slower than speed. And there are like a lot of sub problems. Like once you actually have the fuel source, actually have the negative system, then you have these problems. So there's a lot of sub problem. Like mathematically till this we know like okay, but it's like when you actually start to accelerate a ship, there's a whole lot of issue that we have to deal with. Then we come to the final lane in curve, because the moment you travel faster than light, you end up going in past. Now that is very complicated and hard to understand, and that is why I would suggest you watch that interview, because he will make it more obvious, like because he's the person who started this. So you have to understand, like even Stephen Hawking was against this idea. Basically, he quoted basically chronology, protection, conjecture. Basically, no matter what you do, if you try to break basically space-time continuum, basically you want to go back in the time, something will destroy you. Something, like there is no science behind it. It's not like okay, this will happen or that will happen. Something will happen. You cannot break it. Basically, it's unbreakable no matter what happens. And many people say that it does not mean that we can't travel faster than light. That simply means we cannot use faster than light speed to go back in the time. The moment we try to go back, travel in time itself, then yeah, we'll be destroyed. So you have to understand, like people are looking at the same conjecture at both ways. Someone is like, hey, that actually is very good for us. That means we can do faster than light travel, but we cannot do time travel. So that makes our whole basically ecosystem of time itself intact. So there are people looking at it. So we have dark matter, we have dark energy, we have no idea what it is, and there are a hell lot of sub problems. Like before we can have like engage warp. So a hell lot of problems, and Stephen Hawking's mathematics is not something that you can be taken lightly. So there is a lot of deal with this. It's not as like many YouTube videos I'm watching and people like, yeah, we got it, like, tomorrow we're gonna get, no, it's like, it's unknown on top of an unknown on top of an unknown. It's not something that you can just say that we are here. Like, heck, the moment we discover, like, we can make dark matter, we realize, okay, that was the conjecture was, like, doing that causes some kind of another adverse effects that we do not know of. Like, you have to understand, that is why, like, you have one unknown in your mathematics, okay, awesome. You have hundreds of unknown, then the mathematics is like a joke. It's like a equation trying to find out something that without having any information. So can it be real? Maybe, but I will not put too much faith in it, or that the fact that we even gonna see this in less than 100 years. So this was my presentation on warp drive. I hope you liked it, learned from it. In that case, please click the like button, and if you didn't like it, didn't enjoy it, I would urge you to press dislike, press it twice to show me your extra disappointment, and please leave a comment because I reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.